Okay, in this video we're going to talk about perimeter, circumference, and area of some of our basic geometric figures. Okay, we're going to start off with a square. A square, as you learned in elementary school, has 4 right angles and 4 sides of the same length. Now we know to call those congruent. If we call each side length S, then the perimeter of a square is 4 times S. The area of a square then would be any side squared, since the side lengths are all the same, so S squared. For a rectangle, again, we've got 4 right angles, and we've got 2 pairs of congruent sides. So the perimeter, which again is the length around the figure, would be twice the base, which is one side, plus twice the height, which is the other length. Okay, the area would be the product of the base and the height. So area equals b times h for a rectangle. And for our circle, if you remember in a circle, we've got a center of a circle, and then if you take a segment from the center to any point on that circle, you get a radius. And if you connect 2 points on that circle with a segment that goes through the center, then you get a diameter. Okay, the circumference, which is the perimeter of the circle, has 2 different formulas. We've got c equals pi d, d for diameter, or c equals 2 pi r, where r is a radius. And the area of a circle can be written as area equals pi r squared, where just the radius is squared. Okay, so that's a little review of our perimeter and area for our basic geometric shapes. Let's apply those in some word problems. Okay, so let's say your pool is 15 feet wide and 20 feet long with a 3-foot wide deck surrounding it. You want to build a fence around the deck. How much fencing do you need? When you go to Lowe's or Home Depot, you don't want to buy too much because you don't want to spend any more money than you have to, but you want to make sure you get it enough so you don't have to go back to the store. Okay, so we want to know how much fencing we need. Now remember, the fencing goes around that deck. So this is a perimeter problem. We're not really concerned with the area of the pool or the deck. We're just concerned with the perimeter. So start off with a good diagram. In blue here, we've got our pool. It's a 15 by 20 foot pool. The problem tells us we've got a 3-foot wide deck surrounding the pool. So we've got, in brown, we've got the outline of a 3-foot wide deck. We want a fence around that deck, so we need to know what the perimeter of the outside of the deck is. So if we start off with maybe the height on one side of our pool, and we're going to take that height 15, and now notice there's a deck on either side of that. The deck is 3 feet wide, so we're going to take that 15, add 1 3 to it, and add a second 3 to it. That's going to give us the length of one side of our deck. So that's going to be 21. And then let's take the base, or the other length of our pool, which is 20 feet. And again, we've got 3 feet on this side, 3 feet on this side. So 20 and 3 gives us a 26-foot long fence on this side. Okay, and of course, this is 26, this is 26. If this is 21, the opposite sides of a rectangle are the same, so that would be 21. So let's find how much fence we need. The perimeter formula for a rectangle is 2b plus 2h. So if we substitute in our new base and height, 26 for our base, 21 for our height, distribute our 2's, we get 52 and 42, which gives us 94 feet that we'll need to buy at the store of fencing. All right. Okay, another example. Circle A has a circumference of 15 inches. Find the diameter to the nearest tenth. Okay, so they give us the circumference of a circle. They want us to find the diameter. So we know the circumference. We know the formula for the circumference of a circle. It is pi d. So let's plug in what we know. That 15 substituted in place of the c. If we want to find the diameter, we want to get that d by itself. So using your algebra skills, getting that d by itself means to divide by pi. So right now pi is being multiplied by d. We want to do the opposite operation, so divide both sides by pi. So our diameter is 15 over pi. Or since they asked us to run it to the nearest tenth, put that in your calculator, and we get 4.8 inches to the nearest tenth. Okay, another example. In green, find the perimeter of triangle ABC where they give us the coordinates of A, B, and C. Okay, first thing I would do on this problem, whip out a sheet of graph paper and graph these 3 points. It might save you some time. Okay, even though it takes time to do that, it may save you some time in the end. So I've got our graph going here. I've plotted points A, B, and C. And notice that A and B, if we connect those with a segment, one side of that triangle, that gives us a horizontal line. That's good. We can count in bunny hops, or we can do our difference of our two coordinates to find the length of AB. So from A, which is at -1, to B, which is at 5, that's 6 units. So we know one side of our triangle is 6. Notice that segment BC is a vertical segment. So we can count those as well. Count the tick marks, count the grid lines, or take the difference of the y coordinates. So up 6, BC has a length of 8 units. Now AC though is on a diagonal, so we can't just count the grid, so we can't just count the tick marks. We've got two choices. We can do Pythagorean theorem, since a horizontal and a vertical line form a right angle. We've got a right triangle. Or we can go to our distance formula, which we learned in the last lesson. So let's use our distance formula. We know the coordinates of A and C. They're given to us in the problem. Let's go ahead and assign our x1, y1, x2, and y2s, and plug them into our formula. Simplifying with algebra, we get 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64, 36 and 64 is 100, and 10 times 10 is 100. So the square root of 100 is 10. So the length of AC is 10. So now going back to the problem, remember we want to find the perimeter of this triangle. So we want to add up all 3 sides. So 6 and 8 and 10 gives us the perimeter of 24. Okay, how about one more problem? 2 more problems. Okay, example, find the perimeter and area of the following figure. Okay, this is our figure here in black. This is what we're given. Okay, we're given this funny looking figure, and we're told 2 measurements on it. We're told the height from here to here is 9 meters, and then the width of the base from here to here is 6 meters. Now if you notice, it kind of looks like it's a rectangle with a little half circle on top, and we can assume that that's what it is. So if we want to start off with the perimeter, remember the perimeter is the length around the figure. If you were to walk from this corner along the edge back to where you started, how far you would have walked is the perimeter. So we want to find the lengths of all these sides. So for the rectangle part, we break it up into 2 pieces. Rectangle part we know has a side of 9. Opposite side has to be the same in a rectangle, so that's 9 as well. The base is 6. So for the rectangle part we get 24 meters. Now for the half circle part, remember the perimeter of a circle is a circumference. We only want half the circumference since we have a half circle. So let's plug in what we know into the formula for a circumference. Now, we're not directly told a radius or a diameter, but if we take this here and assume that that's the diameter, here, then this length has to be the same as this length here, which is 6 meters. So if our diameter is 6 meters, let's plug that into our circumference formula. So pi d is pi times 6. Remember, we only want half of it because it's a half circle. So half of pi times 6, well, half of 6 is 3. So that is 3 pi. So this perimeter here is 3 pi meters. Okay, so our perimeter from our rectangle, we have 24. Add to that, the perimeter of our half circle is 3 pi meters. Now, they didn't say to round. They didn't say to approximate or to round in the nearest tenth or hundredth or 3 decimal places. So we're going to assume they want the exact answer without any rounding. This is our exact answer. It doesn't look pretty, but that's our exact answer. Okay, or sometimes we'll call it, that's our answer in terms of pi. That means we don't want to push the pi button in our calculator, because anytime we push that and do an operation with it, we're going to get a decimal. We're going to have to cut it off or round it. Okay, if they asked for approximate to the nearest hundredth, that's when you would put that in your calculator. Okay, but for now, that's what we want. Okay, we still got to find the area of this figure. So now, again, think about this figure in 2 pieces. This is a composite figure. It's made up of 2 types of figures. So we've got our rectangle and our half circle. So our rectangle we know is a 6 by 9 rectangle. So to find the area of a rectangle, base times height, we get 54 square meters for the rectangle. To find the area of our half circle, well, circle's formula for our area is pi r squared. We only want half of that because we have a half circle. So we'll plug in 3 for our radius, since our radius is half of our diameter. So 3 squared is 9. Half of 9 is 4.5. So the area of this half circle is 4.5 pi. Again, if we want the exact answer, we get 54 meters squared plus 4.5 pi meters squared, which was our half circle. Okay, one more example. Okay, let's take another composite figure and let's find the perimeter and area of this figure. Okay, so looking at this figure, that's not one of my normal shapes. It's not just a square or a rectangle or a circle or a triangle, but it's a composite of several of those. So looking at this, I see it's a composite of maybe a square here real big, a little square down here, and a rectangle over here. So I want to think about that when I'm doing the perimeter and area. Okay, so let's start with area this time. Since we're thinking about that, let's go ahead and break it up into those 3 figures. Okay, and let's find the area of each individual figure. So this guy here, since we know this side is 6, the tick marks indicate congruent sides, which have equal measures. So this has to be 6 as well. Area of a square is side squared, so 6 squared is 36. This guy over here looks like a rectangle. So let's see, we've got this side is 3. We don't know this side, but I'll bet we can find it. This side is 6. This whole side has to be 6. We've got 2 of it here, 2 of it here. So 6 take away 2 is 4, take away 2 is 2. So this little piece right here is 2. We have a 2 by 3 rectangle. 2 times 3 is 6. So the area of that rectangle is 6. This little guy down here, we are given a base and a height for this guy. We know it's a square. 2 times 2 is 4. So the area of this piece is 4. So now if we add all those together, we should get the area of our entire figure. So 36 and 6 is 42, plus 4 is 46. We're not given units in this figure, so let's just call it units squared. Now let's go up to perimeter. Okay, now remember, perimeter is the area or the length around the figure. So we want to know all those lengths. So we've got 6 and 6, 2 and 3. Now we're missing this one here, but we found this was 2. So we can fill in a 2 there. We know opposite sides of a rectangle are congruent. So if this is 3, this piece is 3. We have 2, 2. This side's got to be 2 because it's opposite this 2. We know this whole side is 6 because it's opposite this side. So we've got 2 here, 2 here. What do we have left for here? 2. Okay, so I think we've got all of our segments labeled. Now let's add them all up together. Okay, we're going to do some mental math on this one. We got 6 and 6, which is 12, plus 2 is 14, plus 3 is 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, and 34. So the perimeter of this figure is 34 units long.